The next thing we want to be able to do is write an equation to represent any term in the sequence. And we are going to do this based off of the patterns that we see within these sequences. So looking at this first pattern, we want to find the common difference, or the value that we either add or subtract to get from term to term. So if we look at this, the difference between a -7 and a -2, if I subtract those, is going to be a -5, which would be the same difference if I took a -12 and subtracted a -7 from that. I would also get a -5. So in doing that, we've identified that our common difference is -5, and we'll want to keep that as part of our equation. Now, if I'm writing the equation of an arithmetic sequence, it's defined by the nth term equals the first term, which is a1, plus the common difference multiplied by n minus 1. Well, the two things that we need for this are the first term, which we have, it's -2, and the common difference, which we just found, which is -5. So I could say that the nth term, or the general term of this sequence, is -2 plus a -5. I'm just going to put -5 here, times by n minus 1. And I could leave it like that, and that would represent my general term. I could also distribute this out and combine like terms. And if I do that, I end up getting a -5n plus 3. So I could either say that I have the expanded version of an equals -2 minus 5 times n minus 1, or if I distribute that -5 in and combine like terms, I get the an equals 5n plus 3. And this one looks a little cleaner, so I'm going to use that one as my final answer. Now the second one, we see that we've got some decimals, but we can still work it the exact same way. And whether these were positive, whether these were negative, it doesn't matter. We're just trying to find the difference between the values to show that we're either increasing or decreasing consistently. So if I want to find that common difference, I'm going to say my difference between two terms, I'm going to choose this -3.8 and subtract off the -2.7. If I do that, I end up getting a -1.1. And I could find that same thing by subtracting the 4.9 and the 3.8, or the -6 and the -4.9. Any of those consecutive terms are going to give me my common difference. So then if I want to find my general term, I say an equals, and generally a1 plus the difference times by n minus 1. And we know those values, so I'm going to say that an is equal to the first term of -2.7, and then my common difference was -1.1, so I'm going to put that in. If that was a positive 1.1, I would say plus 1.1 instead, and then times the n minus 1. And if I want to, I can simplify that down further and say an equals the -1.1n, and then if I combine those like terms of the -2.7 and the positive 1.1 after I distribute that in, that's going to give me a -1.6 for that constant term. So then this would be the simplified version of my nth term. And then if I wanted to, I could check those. Say I plugged in a 2, I should get the second term of my sequence. If I plug in a 3, I should get the third term of my sequence. If I plug in a 4, I should get the fourth term in my sequence. And if I do that, both of these would end up working. So looking at this, the very first thing we did to find an equation for the nth term is I found the common difference, or the pattern to go from one term to the next term. That could be a positive value, that could be a negative value. It just depends on if it's getting larger or getting smaller from term to term. Then we use our general equation, the an equals a1 plus d times n minus 1, which is saying the first term plus the difference times n minus 1. We plugged in the two values that we knew, the first term and the common difference, and then we simplified that to get a simpler version of those equations.